Hey everybody, here we are, out amongst the stars in outer space, and at some point, I'm going to have to make a transition to planet Earth. Hello, planet Earth, come in. Hello, planet Earth. Hey everybody, welcome to the Epic Flight Academy. This is the instrument rating course. I'm Mike Thompson, and that's right, we are talking about star transitions. But we're not transitioning from the stars to planet Earth. As instrument pilots, we are transitioning from the enroute structure to the instrument approach procedure. Now, to be successful in this course, please use the resources and study Epic's online instrument course. Number 2, study and watch these videos. We are so glad that you're here watching these videos. And number 3, don't forget, you must review all of this in detail with your flight instructor. Now, what about this star transition? Not from the stars to Earth, but from the enroute structure to the instrument approach procedure. The transitions from a star occur at a particular fix, waypoint, or nav aid. Multiple transitions may exist to allow aircraft from various directions to join the star. These aircraft are then funneled to a fix where that instrument approach procedure begins. So take a look at our graphic here from the online course. Now again, this is the Leese Three Arrival. And as we mentioned previously, stars are frequently updated, so you might not even find this star in the current TERPs. We're using this one as a training aid, so please review it with your flight instructor. As you take a look at this training aid, you can see that the transition begins at these 3 yellow highlighted areas. One is the Savannah vortex, the other is the Valdosta VOR-DME, and the third is the Ocala vortex. Now, how do I know that those are the star transitions? Well, take a look at this graphic. We've kind of zeroed in here on the Valdosta VOR-DME, and these transitions are identified by the presence of altitudes that are along the course that extend directly from them. So in this case, you see radial 152 extending from the Valdosta VOR-DME. And along that course, you see the maximum authorized altitude of flight level 180. You see the MEA of 10,000 feet and the MOCA of 2,100 feet. That's how we know that Valdosta is a transition. So again, zero in on this Leese Three Arrival and take a look at Lakeland. Now off of Lakeland, we see radial 356. Is Lakeland a transition? Look carefully. Now, if you answered no, you are correct. I know that Lakeland is not a transition because I do not see the altitudes along that radial. So if Lakeland's not a transition, why is it on the star? Well, that's a good question. Look up at the end of the radial. Radial 356 simply helps the pilot identify the Aladdin intersection. When a pilot is assigned a star, ATC will specify the transition to be flown. So, in our example here, again from the online course, we're coming in from the Savannah vortex, and let's say, for example, ATC has instructed us to fly the Leese Three Arrival via the Savannah transition. Well, how would we do it? We come from the enroute structure to the Savannah vortex, and we fly down to the Schempp intersection. We then change course, and we come down to the Ocala vortex. We change course again inbound to Aladdin. You see why we needed to identify Aladdin. And we proceed inbound to Shim, and finally to Leese, which is where I can connect to some IAPs or instrument approach procedures. Now, the second page of a star has some textual descriptions of the route. So start by reading these instructions carefully. So again, from the online course, we've put this example up here and highlighted the Savannah transition in yellow. So folks, that just about wraps up the star transitions. So maybe I will be able to get safely from outer space to planet Earth. I hope so. We'll see you next time.